Hi everyone. So this video is going to be a second session where we will continue how to interpret the ABG based on the another scenario and another values. So in this video we will talk about the case of Soma Sundaram patient. This patient at present is on ICU setup under ventilator support and control mode with a FiO2 of around 60%. So let's get into the video and we'll interpret this ABG report. So this is the second part of this ABG video. So in this ABG, first we'll note down the PO2 of this patient. The PO2 of this patient is 128 mm mercury, which is again it's a hyperoxemia, and the FiO2 of this patient is around 60% on ventilator setup. See, this FiO2 is 60%, and the PO2 is 128, which is hyperoxemia. But the PO2 is actually low on this setting. So we have to find out whether the lung is normal or abnormal. So how to find whether lung is normal or abnormal? By using the alveolar artery gradient. Alveolar artery gradient. So there's a formula for the alveolar artery gradient. It is 713 into the FiO2 minus 1.25 into PCO2 and minus PO2. So like this, 713 into FiO2 and then minus 1.25 into PCO2, and all together we have to subtract with PO2. So 713. In this case, the FiO2 is 60, it's 0.6, and 1.25 into the PCO2. The PCO2 of this patient is 40.7, and minus the PO2. The PO2 patient is 128. So I have already made the values for the time being. 427.8 minus 50.875 and minus PO2, which is 128. So this is 376.925 minus 128, and if we minus, the value comes around 248.9. So the normal alveolar artery gradient is 15 to 30. So obviously this is more compared to the normal. So there's a problem in the lungs. So this is the formula for alveolar artery gradient. So now first we talk about the PO2. Now we will discuss about the PCO2 of this patient. The PCO2 of this patient is 40.7. And the normal range obviously is 35 to 45 mm mercury. So it's around normal. So I guess the ventilation is good for this patient. The ventilation is good for this patient. So coming to the pH, it's 7.27. So normal is 7.35 to 7.45. So this is 7.2. So obviously it is it's acidosis. And last thing is a bicup, and the bicup for the patient value is 18.5. The normal is 22 to 26, so it is less than 22. So obviously it's a metabolic acidosis. So far we have come to a conclusion that it is a metabolic acidosis. And now we'll discuss about the anion gap. The first video we already discussed how to calculate the actual anion gap. In this scenario also we will discuss about the actual anion gap. Actual anion gap is, if you guys know the formula, it's sodium minus chloride plus bicarb. So in this case the sodium of the patient is 156. The sodium of this patient is 156 minus the chloride is 111 for this patient plus bicarb, which we have seen before. We have seen it's 18.5. So this is the formula. So 156 minus 111 plus 18.5 is 129.5. So now we have to subtract 156. It's around 26.5. So this is the actual anion gap value is 26.5, and before that you have to find the expected anion gap. Expected anion gap is similar to what we have seen in the first video. It's normal anion gap plus pH correction plus albumin if you have the patient albumin level. So the normal anion gap is 12, and the pH correction, that is the pH, if the pH is less than 7.3, you have to deduct 2, and if the pH is more than 7.45, we can add plus 4. And in this case the albumin is not available, so it's 12 plus minus 2, so plus minus 2 is 10, 12 minus 2, 10. So this is the actual anion gap. So coming to the conclusion, this is the expected anion gap. The expected anion gap is 10. So coming to the conclusion, the actual anion gap 26.5 is more than expected anion gap, which is 10. So we can finally we can come to a conclusion that it is AGMA, high anion gap metabolic acidosis. So now we have come to a conclusion that this is an AGMA. So, and the final thing, we have to talk about the bicarb, so that we should not forget. So that is corrected bicarb for this patient. We have to check the corrected bicarb for this patient. For the corrected bicarb, the formula is actual bicarb plus delta anion gap. The actual bicarb for the patient is 18.5 of this patient. Is 18.5 is the actual bicarb, and this anion gap, delta anion gap formula is quite simple. That is actual anion gap minus expected anion gap. So this is the formula for delta anion gap. So this 18.5, you can write it down here, plus the actual anion gap, which we have calculated. The actual anion gap is 26.5 minus the expected anion gap is 10. So this is 26.5 minus 10, it's 18.5 plus 16.5. So altogether it is 35. So the normal range is 24 to 26. This is the normal range for the corrected bicarb is 24 to 26. But in this case, for this patient, we have got what we have got is 35. So obviously this is more than the normal range. So therefore it is metabolic alkalosis with high anion gap metabolic acidosis. So this patient, the patient name is Somasundaram. He is on ICU setup. So we can further predict whether the patient is going for DKA by monitoring the sugar values by hourly CBG, and based on the INN gap we can go for the insulin correction. And if this DKA along with the patient is severely dehydrated, based on the cardiac situation, by seeing the EF and IBC, we can go for the fluid correction if the patient is so dehydrated. So this is the second interpretation for the ABG of this scenario. So we'll talk about the next video with a different ABG sampling. Thank you.